Hey guys, welcome to Deep Dive Coding. Today we solve the LeetCode problem of the day, and that is 3495 minimum operation to make the array elements to 0. So there is a problem that we are given a 2D array, that is query, and query size is representing L and R, and that means the integer array that is consist of the number L to R inclusive. Both are the inclusive. Let's say if we check that L to L comma R is 1 comma 20, then all the elements from 1 to 20 is in the given array. So we have a few operations to do. Let's say we in that array we have to select two integers, that is a and b, from the array, and replace them floor of a by 4 and b by 4. So by these operations we have to do all elements transfer to 0. Now this is the problem, and what we can do, and we have to pick two numbers, that effectively say that we have to pick the two numbers a and b, and we have to divide both of the two numbers divided by the 4. So and that is the considered as one operations. So what we can do, that we try to individually convert to the 0, that how many we calculate the how many operations that needs to convert the 0, and the number of operations, and further divided by 2, so that we can group as 2. So what is the idea over here is, and we cal like yeah. So if we able to find the number of operation to convert each element to 0, then simply divide the number of operation by 2 to group as 2. Yeah, that is the thing. Now let's take an example of that. We are given, let's say, a comma r, that is 1 comma 20. I written over here, that is numbers of 1 up to 20. And if we check that how many operations needs for 1 to be 0, divide by 4. So 1 divided by 4, that will integer division, so it will go to the 0. So 1 operations needed. Similar for the 2 by 4, that is also 1 operations needed, and 3 by 4, that is also leads to 0. So one operation needed. But the 4, we have two operations, that is 4 by 4, that is 1. Let's say so okay, 4 by 4, that will go for 1, and again divide by 4 by 4, it will give the 1, and again divide by 4, it will gives the 0. So two operations needed. Similar for the 5, 6, 7, and up to the 15, two operations is needed. But at the elements 16, we need 3 operations, that is 16 by 4, that gives the 4. Again 4 by 4, that give the 1, and we have to 1 by 4, that's give the 0. So we need 3 operations. Similar for the 17, 18, 19, and 20 as well. So if you closely observe, there is one observations that we can say that individually operations is increase with the change in power of 4. So as the fourth power is changed, let's say here is fourth power is 0, 4 to the power 0 is 1. There is 1 operations needed up to elements 3, and after that, let's say 4 to the power 1, that is 4, that is 2 operations needed, and from the 4 to 15th, there is 2 operations needed, all each elements. And in the 16th, there is change in the number of operations, that is 3. So what we can even if we want to check that for 64, the next power, then 64 by 4, that gives the 16, and that also give 4, that also give the 4, and it will give 4 by 4, it gives 1, and 1 by 4. that is leads to 0. So there is 4 operations to convert 64 to 0. So as the fourth power is changed, the number of operations is increased. So what we can do, what we can effectively calculate that for 1 to 2, how many operations needed to convert all elements 0 in that array. So that is like 4 minus 1, that is 3 into number of operations, that is 1 1 all are 1, and 64 16 minus 4, that is up to over here, like these two, all these two into 2, and 20 minus 16 plus 1, including the last element as well. So we need 42 elements. So another thing is that we can go over it, that a range of 4 to the power p and 4 to the power p plus 1. To convert this range, we need individually p plus 1 operation. We need p plus 1 operation, yeah. And at the last, to group as 2, that we consider each operations, we consider in one operations apply that 2 operations, like divide by 4. So group as 2, we divide the total number of operation by 4, not 4, that is 2, yeah. So over here we try to find we have to calculate the number of operations L comma R. This is a simple observation, like this is most like the common sense. To calculate the number of operations L to R, we calculate the number of operations 1 to R minus number of operations 1 to L minus 1. So in that, so that we calculate the number of operations L to R. So yeah, now we can go through start coding right now. Yeah. Now first of all, there is a return type is long, so we define that LL as long. Now over here is the thing, let's total operations equal to 0, and we go through the each query, that is I equal to 0, I less than queries dot size, and I plus plus. Okay, so now divide and extract the L and R, that is queries of I 0 and R is queries of I and 1. Okay, so now calculate that up to number of operations up to R. So that will calculate operation. We define these functions by letter, like, and over here we pass that R value, and up to L calculate operation up to L, that is not L, that is L minus 1. Okay, so that we can subtract that thing. Yeah, now the difference, the how many operations is needed to L to R, that is actually the difference of it, that is up to R minus up to L. Okay, so total we add this thing, like total operations div by 2 plus div modulo 2. So if the div is the odd number, then we divide that by 2, that gives the half of that, and last one is added, so that div modulo 2, if it is div is odd, then it will give the 1, otherwise it will give the 0. After, at the final stage, we return the total operation. Okay, now we define the function, that is calculate operation, that will take the number as n. Okay, so we have to pass it over here long as well, L. Now we can do these things, that we can take this long, but yeah, that is also fine. Okay, so we can do this thing, that if n less than equal to 0, there is no valid things to do, like if n equal to 0, that number is already 0, so we need 0 operations to convert is that 0 element. Now We take the previous element, that is 1. We start from the 1 and go to the up to the end level, and that is, let's say, operations is 0 and level equal to 1. Okay, so while true, we go through this each level, that is current element equal to 1 left shift operator of 2 into level. That means, okay, that means actually 4 to the power 4 to the power level. We are calculating the up to 4th power. Okay, so if we check this, first we check that if current is exceeding the n plus 1, that means we are not in the range, so we have to break that immediately. Apart from that operation, we calculate the operation, that is current minus previous into level, as we discussed over here. Like, we are calculating that, let's say, in the 4 over 4, the current level is, if we check the 4, then 4 minus 1, that is the previous element, that is 1, and we are multiply with the level, that is 1. We are checking the, we are getting the level as 1 2 3 as the 4th power is increases. Okay, so we calculate the over here operation, and now increase the level, and that is previous element, that is previous, now is the current. Okay, so if this is the, like, if completed, if 4th power is, if n is the 4th power, then we already this terminate over here. Otherwise, if anything is extra, like let's say last segment will be calculated over here, that is operation plus equal to n minus level, not level, that will be the previous element plus 1 including the last elements, and the level is already increased, so into level, and we return the operation. Now I think, yeah, that is fine. Over here, let's say, let's test the sample test case. Okay, now it's accepted for the sample test case. Now we will discuss the time complexity of it. So over here it will run over big O of q dot length. Let's say q is the query, and we have to calculate this maximum iterations over here, that is how much time it will take. So if you closely observe that we have the r value as maximum, r value is 1e9. Okay, so r value is 1e9 at max. So in the old scenario, we calculating the range from calculating range 1 comma 1e9. That will be the worst scenario case. Okay, so r max is 1e9. So if we try to find that how many 4th power that represents the 1e9, so log of 1e9 by log 4, that is log of 1e9 base 4, that will give the 14.94 something. So we can consider as at 15. So we can do the 1e9 needs the 15 iterations at max. So if the test case is if the, like, it's something like this, that range over here 1e9 minus 1 and 1e9, so it will calculate that 1 to 1e9 minus 1, that is not this one, minus 1 comma 1e9 minus 1. Okay. So these are the iterations is needed. So for there is 15 iteration, so to do these 30 iterations is needed. So total 15 plus 15, that is 30 iteration needed, and we can say that at max this will go big of 15. Also this will also have to go big of 15. So yeah, and these are the constant time complexity. Okay, so the total time complexity would be complexity would be big of q dot length into big of, that is 30. That will eventually 30 into q dot length, we can say that that is required big of q dot length. And space complexity Okay, so let's check it. Oh, we are using the constant space complexity, so that will give of one space complexity. And if we want to check that whether it's under the, like, how many operations needed at the odd scenario, so we have 10 to the power 5 uh 10 to the 1e5, let's say 1e5, that is the queries dot length is maximum queries dot length 1e5, and each queries we are calculating 30 operations, that is give the 30. So this will give the 3 into 1e6. This is under the limit, so it will like accept it over here because the time complexity is quite low. Now check that it is run for the sample test case, and let's try to submit it. Yeah, it's accepted. Thank you guys, stay tuned for the more videos.